Assalamualaikum warahmatullahi wabarakatuh. My name is Aifaa Alifah binti Ahmad Nazri and my ID number is EC18105 and my partner is Nur Farhani binti Muhammad Sajiti and her ID number is EC18104. Our mini project is about earthquake detector alarm. Next, okay, the project background is about to detect an early warning earthquake by sending out an alarm and displaying a warning sign when there was a presence of the vibration of an earthquake, which known as seismic wave, that can alert people to evacuate at a safer place. This device also can call the emergency unit if anything happened, especially when a strong earthquake occurs. We have three objectives, which is first, to create a basic microcontroller system using Kill and Proteus software. Second is to enable separation of early warnings for earthquake according to their stages. And last is to easy residents doing preparation of moving to safer place. Next, we move to the flow chart. Okay, basically, in the summary, it divides into three levels of earthquake seriousness, which is low. Low level is the magnitude in range of 1.5 until 5.4, and the median level of earthquake it is from 5.5 until 6.9, and last, the higher earthquake it is bigger than 7. The magnitude is bigger than 7. Okay, I will describe detail in Proteus simulation. Next, we move to the circuit diagram. We use 6 types of components, which is our microcontroller is STM32F103. We use potentiometer as to give a different value of magnitude. We use 2 push button, first to on off the system and also to call the emergency unit. We have 3 LED to describe 3 different level of earthquake, and also we have LCD to give sign of warning, and also piezo buzzer to give extra alertness for the users. Next, we move to the Proteus simulation. First, we run the simulation. Okay, to start the system, we need to press push button A, and then it will display earthquake detector. Virtual terminal also will turn on. Next, we give potentiometer to increase the value to give the magnitude bigger than 1.5, and it will display low earthquake. The yellow LED also will turn on, and also the buzzer. Next, we change the value of the magnitude into the range of bigger than 5.4 but lower than 6.9. The orange LED will turn on and the LCD will show the medium earthquake. The virtual terminal will also show the magnitude. The buzzer also will give a sound. Lastly, we change the magnitude bigger than 7. We can see here the red LED will turn on, and also it will show the large earthquake. The buzzer also turn on. If there is emergency, we can press the push button B to call the emergency unit. We can see at the LCD will show the calling emergency unit. Next, I will pass to my partner, Nur Farhani.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhani binti Muhammad Sajiti. Okay, now I will explain about the coding for this project. Okay, so in this coding, we include the STM32 library and the STDIO library to interface the serial COM. And here we define the RS pin of the LED at port A5, and then we define EN pin of the LED at port A7. And then here we declare the function used for the SART, and here is the function for the LCD. Okay, here is the main coding for. In this part, we declare the push button 1 and push button 2, and we declare chassis H for USRT and float for float analog value and magnitude for the potentiometer. Okay, here are the some character for the display. So in this part, we will initialize the clock for the GPIO-A, GPIO-B, C, ADC1, and USART2. Okay, here we will configure the GPIO-A, B, C as the alternate function. Here it will set the GPIO as the input or output. And here we enable the TX and the USART at pin 13 and TX RX of the USART. And then we set the bound rate to 9600 or 16 megahertz. At this part, we initialize the LCD. First, we initialize the LCD and then it will display the LCD, but the cursor will off. And then we will clear screen and the cursor will shift to the right and it will start at the position 0 at line 1. And then here it will initialize the ADC and it changed the prescaler for the ADC to not exceed 14 megahertz. This part is the looping part. First, we will monitor the push button 1 at port A0. And if the port A0 is low, it means the push button 1 is pressed. Okay, here the LCD will display earthquake detector. And then the virtual terminal will display the analyzing data. And then in this part, here the ADC will perform. It will read the output of the potentiometer and send into the virtual terminal. The virtual terminal will display the earthquake magnitude. So in this part is for the low earthquake. Okay. If the magnitude is less than 5.5 but more than 1.5, the LCD will display a low earthquake. And the yellow LED and buzzer will be triggered. And then it will repeat for 3 times. And if the magnitude is less than 1.5, it will only display the earthquake detector. And then here is for the large magnitude. If the magnitude is more than 6.9, it will display large earthquake. And it's still the same as the low earthquake. It will trigger the LED and the buzzer, but the LED will lights on the red LED. So here, if the push button 2 is pushed or in a low condition, okay, the virtual terminal will display calling emergency unit and the LCD will display the calling emergency unit. It means when the user wants help from the emergency, they need to push the push button 2. This is for the medium earthquake. Okay, it seems like the low earthquake, but the LED we use in this part is orange LED. So here is the function for the USRT write and here is for the USRT read. And then in this two part is for the function for the LCD command and LCD data. And this is function for the delay. And this 3 part here is for the function for the USRT, right? USART. And this 3 function here is for the SART function. Next, we go to the slide. So the conclusion for our project is this system can help people to be alert and protect themselves from the earthquake, and they can simply evacuate early from to a safer location as the alarm sounds. And this system also can alert the emergency unit when people call them for some help at their home. Okay, that's all from us.